Hello everyone, August 18th, I'm back again. Alright, let's do this one. Two keys keyboard. There is only one character A on the screen of a notepad. You can perform one of two operations on this notepad for each step. Copy or copy all. You can copy all the characters present on the screen. A partial copy is not allowed. Paste. You can paste the characters which are copied last time. Given an integer n, return the minimum number of operations to get the character A exactly n times on the screen. So you'll copy all or paste all. And given, so we want A to show up 3 times. So we'll copy all and a paste and a paste. Well, it's a very interesting question. Very interesting question. So we either copy and paste the character which are copied the last time. Okay? Copy the last time. So if you're given n, this screams DP to me, right? It screams DP to me. So basically, if we want to copy n times, right? And we can say if we have the minimum number of operations to copy it from 1, 2, 3 or to n minus 1. Now you want to do n times. So what you can do is find out the minimum that needs to copy n minus 1 times with the last copy that contains 1 character. Right? Or n minus 2 with the last copy 2 characters. N minus 3 with last copy 3 characters. So basically we need to have n copies with the last copy containing 1, 2, 3, 4 all the way to all the way to because we're gonna build an array, right? We're gonna build a matrix for this. Okay, so and since n is 1000, it's O(n) squared. It's pretty straightforward. All right, so what's the base case? The base case is we will copy n equal to 1. Okay, so what we can say is, what will be the row? The row is the copy times the copy, the n, right? The column will be the previous. Hello. Hold on. All right, let's back to it. So we're saying the rows will be n, right? The number of times we want to see, and the columns will be the previous. So for the first row, it is going to be all 0, right? It's going to be all 0. Now, oh my God, this is hard to do without me having a scratch paper or stuff. Have to really think hard. So for the second row, we say we want to copy it 2 times, right? So copy it 2 times. We can say the previous is 1. The previous paste, right? The previous number that's pasted, right? The previous is 1. And then what do we do? If the previous paste is 1, then what we need to do, we will say the previous copy, right, the minimum, because we want, so 1 1 1 1, right? So 1 with 1 is a 0, right? But we need to copy it first. Hold a sec. We're gonna copy all, right? We'll copy all. So we need to do a copy all, and then we paste, and then we can copy all again, and we paste, right? We can copy. So the last time that was copied, right? The last time that was copied. Yeah, it should be, because we saying the ij is to do n equal to get 1 copy with the last copy will be this amount. Which means the first row, yeah, if we want 1 copy with the last copy all applied to 1 is going to be 1, because we have to copy 1, right? We have to copy all is 1, so that's a 1 1. 1 1 is a 1. So for 2, we go to, then we need to, because the previous is we need to paste, right? We need to paste. So there's 2 operations, right? 2 operations, because we need to find out the minimum number of operations to get to 1, right? To get to the previous with the last copy done on that number, right? That's a 1 operation. So here is 1, but we have to paste it. We have to paste it. So we have add 1, so it will be 2. That's a 1 1, and that's the only one. So which means if I say return 2, they should be correct if we do a 2. Right? And of course, we need to say 2 and 2 when we do that, which means we do a copy of length 2. So this is to get 2 with the last copy is 1, right? The last copy is 1, and we can do 2, the last copy is 2, is just by itself. Right, now we go to 3. 3, the last copy is 1, then we need to go to 2, so 2 1 is 2, that'll be 3, right? And then, okay, we can try. Let's try this. Let's try this. All right, so it's going to be DP. First thing we're going to do is we'll create a DP table. N plus 1. Yeah, it's going to be N plus 1 as well. Okay, so we need to fill out the first row. The first row is going to be from 1, right? And from 1. So basically, we're going to say DP 1 is equal to 1. All right, we need to explain what DP is, right? We can explain DP here. 650, right? So dpij, okay, dpij equal to the min operations, right? Min operations to create I number of A with the last copy containing J number of A's. Okay, so that's that, right? And then for int I equal to, well, it has to go from 2 I smaller equal to n I plus plus for int j equal to 1. Because a 0 copy is, yeah, you're not gonna do with a 0 copy. With the last 0 copy, you cannot get anywhere. So right, so j smaller equal to n, and then j plus plus. All right. So for each one ij, so 2, 1 is the first one we're looking at, right? Actually, this is not true. This shall be I, because you cannot go beyond I, because you cannot have a previous copy more than a current one. So what we do is we have the current, right? And then we say we want 1, right? We want the previous is 1. So, and my current number is 2. Now when the previous copy is 1, so I need to know I minus j, right? I minus j. So we say dpij shall equal to dp I minus j, right? I minus, because I say I want to get a current I number of a's, and I want the last copy to be j. So I minus j is that thing. So we do I minus j, the previous, with j number of a copy, right? And that is what plus 1. And if you think about it, it even works when j is equal to I. So when j equal to I, this is 0, right? The first row is always 0, so it's going to be 1. So we'll do that, and once we're done, we'll return the minimum for the last one, right? So we say int res equal to integer dot max value, and we say for int d of dp n, right? That's what we want. Then we just say res equal to math dot minimum res and d, and we'll return this d. Return this res. Okay, let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 1000. Let's see if it's correct. It is terribly not correct. Okay, that's fine. That's totally fine. There's something wrong in our computation. Yeah, just throw it in there for now. Well, we'll deal with this when we figure out. Actually, I don't even know where to throw it.
Oh, the dumpster right there.
Yeah, I need to go there. Okay, so this is not right. All right, this is remarkably wrong, and remarkably wrong.
Someone started running up the stairs.
Yeah, that sounds very, very fun. All right, so we got wrong on 2. That's, oh, I think I know why. Okay, so yeah, this is not going to be correct. We can't just go through every single thing. We have to, because there are some zeros. Let's try this. 1. This is j, right? You have to copy 1. Unless you don't copy. Because n equal to 1, you don't copy. Alright, n equal to 1, you don't copy. That is still not right. What the hell? Okay, we need to print this. DP1 and DP2. What the hell is wrong with my... Oh. Oh, my bad. We cannot reach to n. I completely forgot. But is n equal to 1, you still cannot handle, right? N equal to 1, you still cannot handle. Yeah, okay, let's if n equal to 1, return 0. Let's treat this as a separate issue. We might need to print this again. Okay, let's try this one. Still bad. All equal to 1, 1, 1, 1, 1. Okay, that's not what we want. That is definitely not what we want. Okay, what the hell happened? Okay, let's take a look. 3, right? Huh, that's not right. 2, 2, 0, 1, 1, 2, right? This is 2. There's a 2 we say with the last copy is 1. So we go to 1 with the last copy with 1, and then we do a paste, right? And there's a 2 with the last copy with 2, that's just always 1. And this one always be 1. 3 with the last copy is 1. So we go to 2 with the last copy is 1, and then we do a paste. That's a 3, right? That's a 3. Or 3 with the last copy is 2. If the 3 with the last copy is 2, then we need 1 with the last copy is 2. But 1 the last copy cannot be 2. So that is bad, right? 1 the last copy cannot be 2. Hold on. So 2 well, the last copy is 2. I think these should be like infinite, right? Now the minimum operation, right, to get to 2 where the last copy is 2 is going to be it's going to be however you get it, then you do one more, right? Then you do one more. That is not how I'd expect it to be. Yeah, this is not right. Because the minimum operation, okay, to get n numbers of A's, where the last copy is also n, must be the minimum to get n, and then you do one more. So that is how it's supposed to be, which means all of this is wrong, right? All of this is wrong, and it cannot extend all the way down, because when you say 3, okay, I say I want the last copy to be 2, right? If you want your last copy to be 2, then you require to get 1 where the last copy is 2. But that is not possible. You cannot get 1 where the last copy is 2. So you have to stop early. All right, so there are a lot of things wrong, and I'm gonna say DP, a row in DP. I'm gonna say array stuff fill row with integer dot maximum, right? Max value. And then I set dp11 as 1. Okay, that's fine, right? That is fine. And then we're going to start from the second, and here is not smaller or equal to I, because I cannot go more than half, right? So we shall say sum of I divided by 2, because if I go more than half, right, then we are asking a previous to give me something that I don't really have, right? I don't really have. So this is equal to this. This is fine, right? This is fine. Because what we know is if I have this much, if I have, because I go to n is I is something, right? Because I, let's say 10. I want to get the previous copy is 8. But it's not possible the previous copy is 8. Because you're asking 2 to give you 8, right? That's not possible. But for 10, if you want the previous copy to be 8, right? Then you need, what do you need? Because it is possible if you have a 10, I want the last copy to be 8. So when that happens, you have to do because the previous copy is 8. It has to be 8 itself, right? So you fill up 8 or you fill up 9. Because if it's 9, like you fill 1, okay? And then you do 9 with the previous copy being 8. That is possible. And that's how you can get. Oh, wow, this is, hold on. This is more complicated now. With the last copy, right, I want to fill 10, okay? I want the last copy to be 2. Then I can fill up 8. I can find 8 with the last copy was 2, and then we do 1, right? Or 7, or 6, right? Or 5, I can do that. Or 4, right? Or 4. You say, well, I'll fill up 4, okay? If I fill up 4, the minimum to fill up 4, then I need to fill up 6. Because I want 10, right? With the last copy. No, that's, hold on. I say I want the last copy to be 1 for my 10. Then I go to 9 with the last copy being 1. I can get it, right? Then I paste it, then my last copy is 1. Okay, what are there other ways to get my last copy to be 1? Yeah, because last copy is 1, so you can just copy that. And last copy is 2. You're going to do 8, where the last copy is 2. Right? That's still correct. You can do 8, with the last copy being 2. And that's the only way to get the last copy. Because other than that, what else can you do? Yeah, because the last copy is 2, that means it just means the last copy is 2. You do a last copy and you cannot do anything else, right? You cannot do anything, which means when you get it, it has to only have 2, and then you start filling. You just do all the pasting. You don't do any more copy. Right? You don't do any more copy. You just do paste all the way to the end. And that's, yes, you get 8 and you do that. Right? You get 4 from 6, you get 5 from 5, which means you fill up 5, you copy that, and that's done. Now, how about if I want 6? I want the last copy to be 6. Okay? Then you fill up 4, but it doesn't work. Right? It doesn't work. So you want the last copy to be 6. Okay? That means if you fill up 6 first and the last copy is 6, you cannot get a 10. Right? So you can only you fill up 4. Right? With the last copy doesn't matter, last copy was something, and then you try to fill up 6. Yeah, that doesn't make any sense. Okay, this doesn't make any sense. Can I get 10 with the last copy being 6? That's the key question. Can I even get it? Can I even get it with the last copy being 6? Well, if I want the last copy to be 6, then there has to be 6 in it already. And I do a copy, and boom, it cannot do. You just simply can't. You simply cannot do it that way. Which means you just cannot do. Okay, you cannot do. So we will only go for half. It's not possible to get something. Yeah, you can only go half, right? You go half, and you do this, right? You go half, and you do this. And I just realized because we always just go for the previous row. Actually, no, it's not previous row. It's I minus j, right? Because you just have to do I minus j. But now there's one more thing, because you can do like 5, give 5, because you can do extra copy at the end, right? You can do an extra copy at the end. So what we need is I equal to 2 to n for each one. So the j is, yes, from 1 all the way to half of I. We can never more than half of I. We go to half of I, and that will help us get our current. Okay, if it's more than half of I, then how do you even paste? You can't. And once you're done, as you're doing it, you will record the minimum. Okay, you'll record the minimum. So I can say int current operation, current min. Okay, we can say actually no. So we'll do this, right? Because this is the minimum to go along the way, and we can say dpii, right? When we need dpii, okay? dpii shall equal to math.minimum dpii and dpij, okay? And once it's done, dpii plus plus, because this just, you get the minimum to get that, because you have the plus plus, because you can do the full copy of your current, right? So we have this, and then, right, and then we go to the last part, right? The last part. We need to know the minimum of these. And since everybody is 0, right? Everybody is 0. I was wondering, maybe all we need, maybe we can put this one there as well. So what if, okay? What if 0 is all 0, everybody else is a maximum, and I start from 1, okay? I start from 1, and then if I start from 1, and this is going to be 0, so we don't do this, and then 1 just become 1, right? What are you doing?
Anyway.
Yeah, the facts here.
Oh wait, which one's that one?
And do some experiment. I forgot which. I think it's the the leftmost.
I'll say you need that.
Yes, I do need that one. Alright, so I can do here int I equal to 1, I smaller equal to n, I plus plus. And then instead of row is just dpi. Okay, dpi. Then I don't need this, and I can start from 1. And then everybody is infinite. Then I can do this, right? Then I can do this. In fact, I don't even need to do this because I already done it. It's gonna be dpnn minus 1. All right, so we have a big update on this, and hopefully let's get to this and see. Okay, we have overflow situation. Why will we have this overflow situation? We have this overflow situation because, man, I need to set something right. Maybe because the initial is 0, right? And then I say from 1, and then 1, because it didn't go through any of this. All right, how about this? dp 1, 1 is equal to 1. I put it here. dp 1 equal to 1, and I will still start from 2. All right, I got correct on some of them, but then and then we overflowed because something is just because I go 1 by 1, right? So 1, 2, 3, 4, 5. Okay, we got issue with 5. So now I overflowed. Why? Well, for 5, I say j smaller equal to half. So I basically go I can say system dot out, right, dot print line arrays dot to string dpi. Take a look. Okay, this is I go to 2, 2, 1, 2, 2. Yeah, 2, 2, because 2, 1 is this 2, 2. 3, 1, right? 3, 1 is correct. 3, 2. Now I have some negative because it plus because it's overflowing. So I shouldn't go down max. Then what should I do? Not max. What's the maximum number of steps, operations? You copy one, you do it. So it can be 1,000 times. Okay, 1,000 times. And what if we go, I don't know, 1,000, because you do something, you do, and you copy. Yeah, it won't be any worse than 1,000. But let's put in 2,000. You know, just 2,000. That's how I would imagine. It's just a max value. And let's go back to what we have and see how it goes. Yep, this looks pretty solid. Right, we handled all of them. Now we shall see if it's possible to make it a less complex in terms of space complexity. Yeah, we probably say int max, we just say 2000, doesn't really matter. Yeah, some big value to avoid overflow. Okay, so we're doing ij is I minus j. That's the thing, because you need to do I minus j. I minus j have to refer to a couple levels up, so you can't just do one, right? Yeah, you can't just do one. If it's I minus 1, then you can, but it's I minus j, you cannot. Alright, you want to do, I just throw some more into it. It's August 18th, okay? So it's August 18th today. Yep, looks about right. Submit it. It's an old problem. Very old. And was bad. It was very bad. See, it's the same as the Python one, so it's bad. Which means there is a better solution. This is O(n) squared. I don't know, why am I just constantly giving this bad outcome? Let's see. This is 2 years ago. 1 in 26. How about this one? This one's super fast. Oh, darn. Is it DP? Right to left. Okay, it's a different. Let's see. We have a couple of things. Without early termination. This is with early termination. Oh. I think this is the same as what I did this time. My god. Okay, so DP solution. So I have two DP solutions, right? So I have this is the fast. Yes. Okay, but this DP 10 times, yeah. What is DP then? I mod j equal to 0. Find each j that divides I. We then only need to copy and paste this j to reach I. Find each j, so for each I, okay, find each j that divides I. Then we only need to copy and paste this j to reach gosh. Yep, this is damn. Okay, yeah. I didn't think about this. Yes, ending at this, which means we just keep adding this. Which means for each one, what we need to do is go half and see the one that copy. Oh, yeah. Okay. Yep. Solution number 2. Solution number 2. Let's do this. Solution number 2. Okay, so this is standard DP. We'll call it standard DP, right? This is standard DP. DPI, call it DPI, is the minimum operations to reach I number of A's. All right. To find DPK, right? To find DPK, we go through J from K divided by 2 to 1, okay, in which the J's that divides K can be used as the last copy, right? The last copy, such that the operations needed to reach DPK, to reach K, is DPJ plus K divided by J, right? Because you need to copy and do these number of pasting, right? Let's say K is 8 and J is equal to 2. So you reach 2 first, okay, then you need to copy a 4. You need to copy it once and paste it 3 times, all the way to 4. Yeah, so that's that. So we can technically say dp equals to new int n plus 1, and we are going to set everything. We say arrays dot fill dp max. We can say max is equal to 2000 as what we do earlier, and we do a max, right? And here we say dp1 is equal to 0, and then for int I equal to 2, I smaller equal to n, I plus plus, okay, and then we say for int j equal to it doesn't matter, j can equal to 1, j smaller equal to I divided by 2, right? J plus plus. But it does matter. Does it matter? Yeah, because we go through each one of them, right? It doesn't matter. And we just say dp, we're looking for dpi shall equal to math.minimum dpi and dpj. Well, of course, we actually forgot if I mod j is equal to 0, right? And then we can say dpi equal to dpj plus I divided by j. Okay, then once we're done, we'll return dpn. What's so wrong about this? Hey. Yes, this is still it's still O(n) squared, but because we only need 1 array, so it'll be faster. Exactly, that's very much how I'd expect it to be. Okay, that's very much how I'd expect it to be. But of course, this is not the fastest because we have this mathematical solution which I completely forgot. Okay, what is this? This is called prime factorization. Yes, you copy once and you follow. Copy, paste, paste. Copy, paste, 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 and copy, paste. We call the length of the ith block in the sequence gi. Two important things. The total number of operations can be expressed as yes. After applying G1 operations, we have G1A's, and then after applying G2, we have G1 multiplied by G2A's. Because you copied it, right? You copy, paste, paste, you get a length, which is G1, and you copy, which is G1's length, and you paste, 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 and it says this is G2, right? This is G2 number of operations, and because each time you do it, you are applying the previous number, the previous length, right? So it's going to be G1 times G2. That's the software. We need to find values so that their sum is minimized while ensuring that their product is equal to n. Factorization, yes. Okay, how a block can be minimized? We can break it down because we want to multiply. So these are factors, right? These are factors, and we want the sum of the factors to be minimized. So what should be each factor? Then what we say is if gi is big, okay, then we can break it down into smaller blocks. Okay, reduce the total number of operations from 6 to 5. Which means if you have a big G, right? If you have a big G, it's G of P times Q, right? Into PQ, so P plus Q is smaller than P times it's because we swapping multiplication to plus. So if you can break it down, it always is better. It's never more than using P times Q. Splitting whenever possible will lead to the minimum number. Sum of the prime factors. Okay, solution number 3. Always a fan. The official solution provides a very good explanation why the problem is equivalent to finding the sum of all prime factors of n. Okay, if we want to try to do this, right? The explanation is as follows, right? Given n, we can always break it down to a series of copy and copy and paste, such as copy, paste, paste, copy, paste, 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 copy, paste, right? Let's say, suppose that each sequence contains G steps, right? G steps. Then the total number of operations is G1 plus G2 plus G3. Meanwhile, the total number of A's produced is G1 times G2 times G3, because each subsequent copy copies the entirety of the previous A's produced, right? A's produced. Thus, the problem becomes finding the factors of n such that the sum, right? Such that the sum of these factors is minimized. Now we can observe that if G is not a prime, we can break it down to G equals P times Q, right? And since P plus Q is always no bigger than P times Q, when both P and Q are larger than 1. Yes, so we can 1 plus something. So 1 plus something plus 1 plus something. And then the other is 1 plus something times this, right? So it's going to be something plus 2. And the other is something plus 1 plus multiplication. And that multiplication is definitely bigger than 1. Yeah. This can be proven. This can be readily proved. The best strategy is to break down n as much as possible. That is, finding all the prime factors. The answer to the problem is the sum of all the prime factors. I think does that include 1? That does not include 1. The prime factor of 2 is, was included itself. The 1 is 0, right? 2 is 2, 3 is 3. 4 is 4, because we have 1, 2, 2, 4. 5 is 5. What's 5? It's 1 times 5. Right? So is 5 2? No, 5 is 5. 5 is 5. No, you add them together. This is the total number of operations. Add them together. The 1 doesn't count. Okay? 1 doesn't count. So 1 is just nothing. And 2 is, the prime. 2, 3, 4. 4 is 2 plus 2. 5 is 5. 6 is 2 plus 3. So that's 5. Okay. So we're going to find the prime factor. So we do a bunch of 2 first, right? And then we do, 3s. But we can just go one by one, right? Yeah, I think int res equal to 0. So we can just do 1 by 1. And factor is equal to 1, equal to 2. Okay? And say while n is larger than 1. Okay? Then we say if n mod f is equal to 0. Then we say n divided equal to f, and the rest plus equal to f. Okay, we just keep doing, and then we say else and f plus plus, and at the end we'll return rest. Okay, let's try this. Let's see if we got it right. I use another while loop, which is fine. We hold 1. It's just also okay. Yeah, I guess it's fine. So this is going to be, and they call it on, which is true because you have to go through the number of prime number. Yeah, I would take on total. You have to go through them n times. This will be fast. So take no time at all. Just a bunch of loops. No data structure, no nothing. It's just a bunch of loops. All right. Oh, it's a good question. Very good problem. Multiple ways to do it. And yeah, you also have a very smart way. All right, that'll be it today. I'll see you guys tomorrow. Adios.